I made a clock using an Adafruit Clue, and it has the most useful feature any clock can have. I'm going to unplug the power. It forgets the current time. I'm going to plug it back in. It restarts, and it takes a few seconds to restart, and it restarts, and it restarts. And now take a look. It doesn't know the time, but it's doing a Bluetooth scan. It found what's called a Bluetooth current time server. I've got it running on a laptop. And it will reset itself, which is exactly what you'd expect a clock to do. Now what I'm going to do is I'm going to show the three basic parts of this clock, which is it's got a display, and I'm going to show you the code to make the display work. It shows the time, and that means it's hooked up to the real-time clock. And I'll show you how that works as well. And then lastly, it does the Bluetooth thing to reset itself. And you can add that to your device too. It's easy and straightforward. And I'm going to show you how to do it. Let's take a look at some code. Here's the code for the Clue clock. Now this code, by the way, is all CircuitPython, which is a really handy system that the Adafruit company has set up for many of their devices. It's really powerful and really easy to use. The editor I'm using is the Moo editor, and it's the standard editor that they provide. There's three features I'm going to walk through, and two of them are fairly simple. The first feature is the display, and I'm going to show you how to initialize that and then use that. Feature number two is the real-time clock, and I'm going to talk about why a real-time clock is important. And the third one, which is the most advanced, is how to hook up your code, or this code, into something that is advertising a Bluetooth service, and then pull data out of that service. That's more complicated, and we'll see how that all works. So for each feature, there's going to be like some imports, there's going to be some functions to deal with it, there's going to be some setup, and then it's going to actually get used. Let's step through it one at a time. Firstly, for our display, the only thing we need to import is the actual Clue device itself. We're going to pull it in from the Adafruit Clue because it's an Adafruit thing. For the setup, here's our setup for feature number one. We're going to set up the display, and we're going to use what's called a simple text display, which lets us put some lines on the screen. We also get a title. We can scale the text, and scale text 4 gives us on the Clue device like 10 characters across, which is about right for a clock. And we set up some colors, which is like white and like a red, green, more of a bluish shade here. And then the title is a color and all that good stuff. We've also got some functions to display data. And this is something I like to do with all of my projects, which is to have a very simple set of functions to display data. So for example, to display time, and we're going to use this struct time is because that's what the real-time clock is, it turns out, is going to generate. So why would we not use that? And so we're going to make a time string, and then we're going to display it. And we're going to display it on Clue display line number 0, which is the first one. And we're going to say set the text to be the time string, and we're going to center it by adding this little space here. Line number 2, which is array index 1, is going to be the date. And so we format the date in a nice way. We're going to display a DAW, which is day of week, and we're going to display that as well. And we're pull the data out of this struct time. And the values I listed here. It's just handy it's a tuple, so it's handy to know what's what. The most important thing is where at the end I actually show the data. Let me just say, for a person who can get a little impatient sometimes at reading the instructions, like it took me an embarrassingly long time to realize that the reason nothing was displaying is that I wasn't telling it to actually show the display. Well, great, we can display time, and then I got these two others that display the word BT scan, and then BT with the result. And that's to handle the Bluetooth stuff, and that gets displayed on line number index 2, which is line number 3 on the screen. So we got our features, we got our functions. It's been initialized. Let's look at how it actually gets displayed. And the answer is at the very end of the text here, while true, so forever, we're going to pull the clock time out of the current date and time out of the clock. And that's in that structure that I mentioned before. and we're call display time, and I'm going to call it with our display, because what else are we going to display? Now, this is ordinary stuff. Like, this is stuff that you will see in almost every app you write, especially for the Clue that has that beautiful display on it. Now, let's talk about the real-time clock, which is something not everybody uses. The real-time clock does a couple of things. One, it keeps track of time very, very accurately in a way that you can't normally do. Like, it has special stuff in it to make it more accurate. The other thing is, as long as it has power, it will keep track of the time, which means you can reset this device and it'll still keep track of the time, which is handy. If you lose power, though, it just resets to like the year 2000 or something. So to use it, we have to import the real-time clock RTC and the time. And you'll notice that I've got some functions for feature 1, but I don't have any functions for feature 2, the real-time clock, or feature 3, which is the Bluetooth, because they don't need it. But there is a setup, and the setup is you call RTC, and that gets us the real-time clock, and I just call that clock. And then, because I may as well, I just display the current time from whatever the real-time clock currently has. And that's kind of it. Like, nothing else needs to be done. It's set it up and then kind of forget about it. You will remember, of course, that clock, like, we pull the clock out, date time out of the clock every second or so, because like that updates the clock, and we know that it will stay up to date. Okay, now let's go into the deep, deep part, which is how the heck does the Bluetooth work? So let's stop for a moment and talk about Bluetooth and how this works at all. The way Bluetooth works in general is that somewhere in the world there's a server spitting out Bluetooth and what they call the Bluetooth current time service. In my case, that Bluetooth current time service is sitting on my laptop like 3 feet away, which is good because Bluetooth has a limited range. Where did I get that app from, by the way? And the answer is I downloaded it from the store. How did the store happen to have it? Because I wrote it and I put it up in the store. And I've got the code for it available on GitHub. It's just a simple little C# thing that advertises the one service. But we are a clock, and so we're a client. We're the client of that service. We're the ones in charge of like deciding to use the service and then pulling the data out and then doing with it as we will. And what we want to do with it is we want to use the data from the current time service and initialize our real-time clock. So let's take a look at how that can happen. Step number 1 is we got to import Adafruit BLE. And just as a reminder, when I read the Clue manual and it said, hey, you'll want all these libraries and stuff on your Clue, the one it didn't include was the BLE. And so you got to make sure the BLE is actually a library on your Clue device, just like you do for all the other libraries. As a reminder, the Clue device may not come with CircuitPython setup originally, so you've got to like initialize it to be CircuitPython. Otherwise, it becomes like an Arduino or something else. Now, the other thing we've got is this BT current time service client, which is this code right here, which I wrote in order to work with the Adafruit Bluetooth system. The Adafruit Bluetooth system, you either use it the way they intend it, or you will not get any good results whatsoever. So you got to use it the way they do it. And I'm going to show you how they want to do Bluetooth things. So like I say, we don't have any functions here in this file for the Bluetooth because they're all in a different file in that BT time service client Python file. But we do need to do a setup. And we're to start by updating the clock to say, hey, we're about to start scanning. And when we're done with our setup, by the way, we're going to stop and we're going to either say, oopsie, we don't have a clock, or we're going to say, yay, we do have a clock. And we're going to initialize the real-time clock. So the whole goal of all of this is somehow we're going to pull the current time off of my laptop, as it turns out, which has the Bluetooth time service running. We want to pull that data out and initialize the real-time clock. That's our challenge. And the way we're going to do this is I have a runner code, which is a wrapper for how Adafruit does stuff. And we'll see what that means. I create one of them by creating one. I'm going to find me my Bluetooth radio, and then I'm going to scan. And this scan is the one single function in this thing that I'm calling time service, but it's that runner service. I'm going to say, hey, you BT current time service client runner, scan right now this radio here, and then give me some data. And the data it's going to come back with is this, which is the data from the service. And it's going to have a year and a month and a day, an hour, a minute, second, and then some other stuff that we don't care about. And we're going to take that data and we're going to convert it into that structure that the display uses, which is also what the real-time clock needs to initialize. And this is how you initialize the real-time clock. You just pass it a structure with the data, and after you do that, it will then every second update this date time value to be the current time. Great. Let's see how the heck this scan works. Now it's going to take in a radio, and what we expect to do is like scan Bluetooth advertisements looking for stuff. And yep, that's what it does. Let's take a look. As a reminder, like I wrote all of this, so that's how I know how it works. There's a bunch of imports that we're going to need, and here's our scan function that we're called, and it takes in a radio. And I got a bunch of prints and stuff here because, man, figuring all this out was not an easy task. But here's the fundamentals. What we're going to do is we're going to call here. This right here is the key. We are going to call this scan once, and that's going to do a single advertisement scan looking for any Bluetooth service out there that claims that it does the Bluetooth current time service. I say claims because, like, it's some random service I hooked to. It's like using Wi-Fi at an airport. Like, it's probably the airport Wi-Fi, but you never really know. Once we have the connection, and that's what this connection here is, we're going to connect to it. Awesome. And this will get us a object that has data, and we can pull the data out, and that will be that tuple that we want and that we want to return. And that's what I'm setting this retval to. I love using the word retval. I've been using it actually professionally for programming, like since I started programming a long time ago. We're also immediately going to disconnect. Like, we're the client here. Like, it's up to us to decide how we want to use this service. The way we use this service is we pull one snapshot of the data out of it once, and then we're done. We don't need to ever deal with it again. If we wanted to, by the way, we absolutely could just like keep on waiting for it to do stuff and like updating based on like constantly updated time values, but I don't actually do that. All right, so this scan once then is going to be this super critical method. And once again, it's a method that I wrote. And what it's going to do is it's going to look for advertisements that do the service that we're interested in. And by the way, how do we know what service we're interested in? You'll see in a moment. So we take our radio and we say, and here's our BLE. And so now we're finally actually calling into like actual like Adafruit methods that will do radio stuff. And we say, hey, I want you to start a scan. And I want you to tell me about things that are advertisements for Bluetooth where it lists the services that they advertise. And we got a timeout too, because we don't want to do this forever. We're going to do it, in fact, for 15 seconds. Start me a scan, make me a list. Now, this list, we get it right away, but it will be filled in over time. It's a smart list. I'm going to look at every advertisement in that list and we're going to count how many we see because I'm always a snoop that way. I love knowing how many there are. We're going to remember the address. We're going to remember that. And we're going to actually like say, like, if the address is one we've already found, then we don't need to see it again. Like, if we've already seen an advertisement and not wanted to look at it, then why would we look at it again? So we'll just skip over. There's also advertisements and responses, and we don't care about the scan responses either. Otherwise, we'll add it to the set of stuff, which is addresses that we've already looked at. And then we're going to say, hey, is this advertisement a thing that does a provide services advertisement? And it really ought to, because like that's kind of what we told it to look for. And we're going to get this list of services. out of the advertisement, and we're going to say, hey, is this UUID in this list of services that has been advertised? Where did we get this UUID from? Hang on, it will become obvious. If that thing that advertised services says that it does that service that we're looking for, the Bluetooth current time service, then for goodness sakes, actually connect to it. And then we got our time service connection. We're all connected, which is all good. And then we're going to return. Why will we return? Well, once we find one, we don't need to like find more. And that's why, if you look carefully, it's got a break. So we're going to break out of the loop. And the loop itself is a scan once. So we're going to just pop right out. We're also going to stop scanning because why would we continue to scan? We want to stop. And we're going to turn that connection that we disconnected. And so that connection is this right here. We did a scan once, we found the connection. It's not none, so we know it actually exists. It's a real thing. It's a real thing we can connect to. And then we're going to connect to it, passing in the connection. We're going to get the service back out. And the service is going to have the actual data in it. So how the heck does this thing work? Which is also a method that I had to write. Connect to current time service. And here it is. We take in a radio because it turns out we're going to need that. And the connection is that connection to the actual live and device. And remember, it's an actual live device. Like we've connected to it. We should be able to pull stuff out. And it's called connection, which isn't quite the right word. It's like this is our live Bluetooth device sitting somewhere. It's got a bunch of stuff and we can query it for stuff. And so our very first thing is to ask it, like, is this UUID? Where'd that UUID come from? Hang on. All will be obvious later on from here. If the UUID is one of the things it has, then is not something it has, then return, because then we don't care about it. If we're not connected, then also return. These things should not happen because we asked for this thing specifically before. All right, so great. Now we're going to take this connection, which is that live Bluetooth device, and we're going to say, pass in, all right, what the heck is this? This, and you'll see it highlighted down here, this is a class. It's not an object. I haven't instantiated anything. It's just a class. This connection object is super smart, which actually I find irritating. This connection object is super smart, and when you ask it, please pull out this device from it, this thing from it, it will then make you one. It'll create a new object of this type, the BT current time service client. And once you have that, that's an actual like live Bluetooth device that you can now ask questions about like what services it has and actually pull data out of those services. I didn't make up this system. Adafruit made up this system. I actually prefer the way Windows does stuff. For there, like once you have a connection, you just ask it, like, give me a list of all your services and it'll tell you. And then for each service, you say, hey, give me a list of all the characteristics in that service and it'll tell you. Then you say, hey, that characteristic there, give me the data and it'll give it to you. Instead of trying to be smart, it doesn't, the Windows side doesn't try to be smart, but this Adafruit side really does try to be smart and be very Python-esque about stuff, and it drives me up the wall. Anyway, so if it turns out that live connection we have to that live device actually is a Bluetooth current time service, then it's awesome. We'll actually get the service out. I call it service here, and it is a service because it is a service, but it's also kind of not, but it kind of is. Anyway, if it's not none, that is that we actually connected to it, then we can call this get time string. This is also a method that I wrote. And what we're eventually going to return is the service. I could have returned the data here, but I decided to return the service. Now, that way, this code is a little more generic, and it's only the code up higher that's less generic. So the connect to current time service will return me like a live device that's ready to be used. Let's scan back to our scan routine. We call the current time service. What we get back is this live device, this live connection to a live Bluetooth thing that we can actually pull data out of. And here we actually like pull out the data. And at that point, we decide to disconnect because why would we keep on doing it? Time service, yeah, be right. We disconnect the connection to the device and we reset it to none, and then we return retval, which is the data from the service. All right, great. What the heck is that data? Let's take a look. And what is this class? Why do we even need it? How the heck does it get used? Here's the deal. When you call into the connection and say, hey, get me a service out of that connection, what the smart Python stuff in this connection is going to do. I mean, it looks like a list here, like you could iterate it through or something, but it kind of isn't. What that smart thing does is it says, aha, take the class that you passed in with this UUID, which is a standard UUID of value 1805. The Bluetooth SIG defines all these. Grab that. If there's a service with that UUID, then yay, we got something. At which point it will hook in all these characteristics, like this one called data. What kind of characteristic is it? Well, the Adafruit people have a bunch of different characteristic types that are handy shortcuts to making a characteristic. And so in this case, we know that the UUID for this characteristic of the standard service for like just pulling out data is UUID 2A2B. So that's its UUID. So the Adafruit system will hook stuff up for you, and then it will read the data automatically. How will it read the data? Well, it's going to use this struct format because it's a struct characteristic. And if you provide the string of the struct format, it will essentially unpack all of the data that would otherwise just be a binary array. This format is in the same format that like pack and unpack use. The little less than sign here means it's little endian because Bluetooth is mostly little endian. The H means it's a half word, which means 2 bytes, and the is all bytes. How do I know it's supposed to be that? The Bluetooth SIG told me what the value should be. Well, this is all good, but remember when we pulled the data out of here? Like right here, right here, right here. Eventually I'll get to the right here. This here where I said, hey, that service, that's the service, that's an instantiation of this class. It has data. And then that data is just like a tuple. But does this look like a tuple to you? No, it does not look like a tuple to me. That's because this data is part of the class. When the Adafruit Bluetooth system makes one of these objects of this class, it will make a new data value for that object, and that data will be a tuple, and it will fill that tuple in with stuff using this format right here based on struct format in the pack and the data. It's kind of a complicated system. Here's an example of us using that right away. Like here's self for the get time string. I can just say, look at the data and it'll be whatever it is. And if you wait a little bit and then ask for the data again, it'll have been updated because this is a notify service. So it'll be notified. And what is that tuple? Well, it's all this stuff: year, month, day, hour, minute, second, and then some more stuff I don't care about. The Bluetooth SIG does care about them, which is why they've got it here, and they have a full explanation of what they mean. And then I make up a string and then return that string in a nice, easy looking format. So to recap, in my code in the clock, when I want to use Bluetooth, I include the import Adafruit Bluetooth, remembering to put that library onto the chip because it won't by default from the instructions that they provide. I'm going to import my set of classes, and remember there's 2 classes here. I mean, I only really care about one of them, but there's 2 classes here. And then when I want to actually initialize the device, here's all the initialization code. It's going through this one at a time. I'm going to make my runner, which is the easy to use version of all the Bluetooth code. I'm going to grab my radio because I'm going to do radio, and I'm going to do a scan, and it will return either a tuple of data or it will return none. If it does return a tuple of data, it will return this hour, minute, day, hour, minute, year, minute, year, month, day, hour, minute, second, and more stuff that I don't care about. which is super easy to then convert into the time structure that the real-time clock uses, and then initialize. Well, that was kind of long-winded, kind of by necessity because it's a lot of stuff to go through. But the neat thing about this is that once you learn how to do one of these, you can now hook up to almost any kind of Bluetooth service. There's a couple of different kinds of characteristics you can hook to. Uh, they've got some stuff, and then if you look in my GitHub, like I've got some more there as well, and I have some more examples of how to do this. That means that your Clue device, it can now connect to all these Bluetooth things, which is pretty awesome. And if you've ever had a Bluetooth device where you said, hey, you know what? This would actually be more awesome if I could display the time. This would be more awesome if it knew the time because then I could like coordinate better. I can do an alarm. I can turn the lamp on at a time or not at a time. I can actually know what today's date is because I'm doing a phase of the moon or I'm showing star values or I'm whatever I'm doing. Like this is a way to get a date and a time, which I think is freaking awesome and something that you can't do otherwise. So I'd like to thank you all for the small number of people who've listened all the way to the end for this. Thank you very much for listening and good luck with your own project.